Hello, everyone who's joined so far. Just want to let you know that we'll be starting in 4 minutes. So 4 o'clock Pacific time, we'll get this started. As the webinar is going along, feel free to ask any questions. You can even start asking now, I suppose. You can drop questions in the chat, or there should be a Q&A somewhere. Yep, Q&A. Q&A is probably a better place. So go ahead and feel free to drop any questions in there. I'll probably try to answer the questions when we're at that section, whatever section's relevant for those questions in the webinar. And this is an intro webinar, so it's a good place if you're completely new to using FlowJo. If you've been using FlowJo for a while, this might not be the webinar for you, but there might be some useful tips that could help that will occur during the webinar. So yeah, we're going to give it 3 more minutes and then we'll get started. All right, my clock says it's 4 o'clock, so I'll go ahead and get started. Um, so hello everyone, I'm Dylan Hinson. Today we're going to be doing an Intro to FlowJo webinar. So if you're new to using FlowJo, this is a good place to start. As I go along through some slides, and then I'll repeat again doing a live demonstration. Um, Feel free to ask any questions as we're going along. You can put questions in the Q&A, and I'll try to respond to them. You can also put questions in the chat, and I'll try to respond to those as well. Um, So yeah, I'm gonna go ahead and get started. This is a great place to start if you're new to using FlowJo. Um, okay, so here's a slide about FlowJo. It's obviously a um, very popular analysis tool for flow cytometry data. Um, so the basic steps of a FlowJo analysis, like why do we even want to use FlowJo? So the reason to use FlowJo, I guess, is we can kind of perform maybe the 4 basic steps, plus also some additional things, but the 4 basic steps of a flow cytometry analysis, which is probably starts with compensation, and then you define populations through gating subsets. You try and visualize those phenotypes, and then So like making graphs for papers. And then lastly, we try and generate some statistics to get statistical comparisons or statistical differences between the expression of certain markers in populations. So that's, the basics of why we use FlowJo and what FlowJo is used for. There's more advanced things we can do. There's some advanced graphics we can make. There's some advanced statistical comparisons, but um, the gist is, this is what our goal will be today is to get these results. So um, let's kind of dive into looking at FlowJo and what it looks like and just kind of get ourselves oriented. So this is the FlowJo version 10 workspace. So when you first open FlowJo, this is what you'll see. And just to get a basic idea of what we're looking at, the very top is the ribbon. The ribbon is where all the buttons are. The different tabs in the ribbon, so like where it says FlowJo, File, oh, I think I have a cursor, FlowJo, File, Edit, Workspace, Tools, and Configure. Those will give you access to different buttons that you can press to do different things in the analysis. Um, We'll look more at specific buttons later. Um, and the next section is our group section. This can be used to group data together, samples. So maybe there's different experimental conditions we want to look at. So for instance, we might have some controls, like single stain controls. We want to group that data together, but then we'll have a separate group for our fully stained, patient samples that we're analyzing. Um, and then here, this third part is the columns. These are the headers that describe what's occurring in the sample area. And so the sample area is this main section down here. This is where we'll spend most of our time. The sample area is where we will load data and do our gating, and even our statistics can be shown in the sample area. So the first thing you obviously want to do when you do an analysis is load data. Loading data is pretty easy. You can drag and drop a folder containing FCS files into FlowJo. That's why it says drag samples here. Drag and drop the data in, and it will load the data inside that folder. That's my favorite way to load data. There's also the Add Samples button, which is highlighted here, or this plus sign here. There's a lot of different ways to do everything in FlowJo. We usually give you multiple options for doing things in FlowJo, so you can use whatever you think's fastest. Yeah, so we can load any FCS file into FlowJo. FlowJo is agnostic, so we can take FCS data from any cytometer. We have tools for doing spectral analysis as well as conventional flow analysis. We also can load MQD and LMD files from those specialized cytometers. Um, yeah, and so cruising along, let's take a look at some components of the FlowJo workspace. The ribbon, as I mentioned, these are the different ribbon tabs. They control what buttons are available to use. If you're looking for a button, I would just click through the different tabs until you find it. There's some organization to them, but for the most part, I would just click along until you find whatever button you're looking for. There's also a few buttons kind of always at the top of the FlowJo workspace here. That's the compensation wizard button, which is only available when we're in a compensation group with our compensation single stain controls. And then there's the table editor and the layout editor buttons. These are two other main windows. The table editor is where we can create statistics. The layout editor is where we can make visuals and graphs. And so we'll look at those more in a moment. So groups is a way we can kind of group data together. So for instance, here we have some different simulation conditions that were grouped together. There's a create group button, so you can make new groups. By default, all the samples will always be in the all samples group, but you can make additional groups to kind of subset your data. So that way you can have specific gates applied to specific conditions or maybe specific statistics, or maybe you just want to make specific visuals with specific samples. You can group them together this way. So if I want to apply specific gates to a group, I can just apply those gates to that group, and then you'll see those gates listed here, and these gates will only be applied to the samples within that group. All right. So then there's the samples section. The sample section is the main part of the FlowJo analysis, really. It's where we'll list our FCS files, and as we draw our gates, it'll list the subpopulations that we're creating as we subset the data. And so the goal, of flow cytometry often is to identify phenotypes. And so we're drawing gates on data to get down to subsets. And so you can see here we're starting from the whole sample, we identify some lymphocytes, singlets, live, CD3, etc., down to subpopulations here. And there's some statistics that will be included as well. So the percentage of the parent, for instance, here it shows you the number of cells, and you can have some other keywords as well. So the gating hierarchy, again, I kind of was just mentioning the goal of gating is to get down to subpopulations of interest. So it displays, starting at the very top, we have our parent population. In this case, it's of course the whole sample. And then we subset that sample, and each indentation here represents a subset of, the groups above it. So for instance, live is a subset of singlets, etc. Um, Now some of these you can see are side by side. They're next to each other. They're not indented from each other. Those are sister populations. They're at the same level in the gating hierarchy. So they're not a subset of one another. They're completely independent from each other. In this case, it's just I drew a live gate and I didn't like my live gate, so I made a better live gate. You can see they almost contain the same number of cells. One maybe is a little better. And so I use that for the future. So none of these subpopulations, they're only applied under this live 2 gate. None of them are under the live 1 gate. Um, and so anyways, you can apply these populations once you've gated on a single sample to your other samples in the workspace by dragging and dropping these population nodes. You'll want to apply them in the order of the gating, of course, and maintain that order. You can also apply them to the group to apply it to all the samples in the group. And again, we're going to look at this live when I get to the live demo in a moment. Okay, so the graph window, this is where we'll see our visualizations. If we click twice on a population, we'll open that population as a graph window, and we can look at, different parameter combinations. We can draw more gates on the window to get more subsets. And so you can see here, just to get an idea, there's a lot of different ways we can visualize the data in FlowJo. And so the default is the pseudo color, which is a density plot. It's telling us how many cells are in a certain area. The red is a high density area. The blue is a very low density area. So that's our default for a two-dimensional plot. But we have a lot of other options as well. So you can always use contour plots, a true density plot, a zebra plot, different ways of showing the density. There's also dot plots, which is just black and white. And then there's you can make a color map. So you can use a third parameter, in this case it's PE, that we're using to show the expression of the PE within these cells. So the negative cells actually in this case are PE positive. And then lastly, we of course have one-dimensional plots that are available as well. So instead of looking at 2 parameters at once and the expression of both those parameters, you can look at 1 parameter. Okay, so to our left is the graph window again. That's when we are looking at a single population. We double click on it and it will open up this graph window. Again, if it's not making sense right now, we're going to do a live demo in a moment. And so hopefully it'll make more sense then. But within the graph window, one thing we want to consider is this T button here located next to the axis. This allows us to set the transform within the graph window. So if the transform basically is the scale of the data. It's, what kind of transform we're using to visualize the data. The default in FlowJo is bi-exponential, which is a combination of logarithmic and linear scaling. So it combines the two together, so that way we can see negative values. It allows us to compress the area around the 0 where we have a lot of negative values and visualize our positive values in a logarithmic scale. So if we want to change the scale, we can press this T button and choose Customize Axis. And then we can change the scale, the min and max. We can change the type of transform and other things about the scaling here in FlowJo. And again, we'll look at this more in a moment, but setting the scaling is very important. For instance, in this case, I have a bit of white space here that I'm really not using in this plot on my x-axis. I could further separate these two populations if I remove this white space and move this positive population closer to the right-hand edge of the plot. It might get us better separation of the two populations. In this case, they're pretty well separated, but in other cases, it might matter more. Okay, here's some examples of transforms. We have this first transform is really bad because the data is going off axis. We can't even visualize some of our negative data, or the negative on the y but positive on the x, for instance, here. So that's not ideal. We probably want to see all of our data visually. This is kind of the opposite extreme. All of our data is on axis, but it's really compressed. They're really squished together. And this is it's really hard to separate the positive from the negative if they're squished together like this. So we'll want to separate them more. So this last transform, you can see they're much better separation. So the positive populations over here, and then are clearly separated from our negatives. Okay. The layout editor, I kind of mentioned it briefly before. So if you press this L button or this L button, it opens up this window called the layout editor. This is where we can make our visuals. We can do that by dragging and dropping populations into the layout. It'll make a visual of that population, whatever we were looking at last. There's a lot of ways we can change the properties of these plots in the layout. So we can change some of the colors. We can change what we're looking at in the X and Y axis. We can change the plot type from a pseudo color to some other plot type. So the layout editor is good for making our visuals, kind of orienting plots together. We can, move multiple plots together so we can get multiple samples and compare them in the layout. So there's a lot of different ways to make visuals using the layout editor. Okay, so the layout editor, again, this is the basic window. When you first open it, it's going to look like this. It has some buttons to allow us to create new layouts. As well as some tabs similar to the FlowJo Workspace tabs that give us options for different buttons and different things that we can do to adjust the visuals. So pressing these tabs at the top here will change what buttons are available. The plus sign makes new layouts. There's space down here. This is where we can make our plots and edit them and add whatever text and other elements we want to the plots. And basically, it's like a blank PowerPoint slide in the bottom part here, where we can kind of put some visual elements together to make some sort of figure or display that we want to make. Also, I'll demonstrate this later, but we can, in the top section here, we can batch. What batching means is we can apply the same analysis to multiple samples. So if we make visuals for a single sample, we make some very nice visuals that we like, but we have 20 other samples, obviously we want the same visuals maybe for those other 20 samples. We can batch the analysis and it will make the same visuals for the 20 other samples. So that way we have all of our visuals for all of our samples. Okay, yep. So I talk more about that batch report here. We can set whether we want to batch our criteria for batching. Usually it's just each sample maybe. We can set some criteria for how we want the batch report to look. So like how many plots per page, for instance. And then we can go ahead and create that batch report and it'll make a new layout with those batched visuals. Okay. And then of course, most importantly, we want to export these visuals that we're making. So once I've made this batch report, for instance, with all these visuals, I want to export it. You can export to a variety of export options. Generally, SVG or PDF are going to be your highest image quality images. So I'd export as one of those two. They're vectorized, which is nice, and you can edit them in other softwares if you wanted to. But there's also other options like PNG and JPEG, which might be useful for some other softwares as well. Okay, and then the next tool I want to talk about is the table editor. The table editor is kind of similar to the layout editor in that it's a separate window that will appear when you press the table editor buttons, which are here or here. And it'll open this window here, and similar to the layout editor, we can drag and drop populations into the table editor to make statistics for those populations. In this case, though, we'll probably also want to add some statistical nodes, such as what these are here, to the FlowJo workspace that we can drag into the table editor to visualize those statistics as well. And so you can see we can fill this table with statistics that we want to generate. And then when we want to actually calculate those statistics, we'll hit the Create Table button here. And it will create these statistics not only for the sample that we're adding the statistics from, but all the other samples as well. So just to show some other things in this, like the layout editor, the table editor, we can make new tables using the plus button here. As I mentioned, we can quickly generate tables across different samples by using the Create Tables button. It'll go through all the samples and make a table with all your samples in it. We can change where we want to export the statistics. So usually we want to export it maybe as like a CSV file or an Excel file to our computer so that way we can store those statistics and use them later. And then here's the space where we can add statistics to calculate. Once again, the different tabs here control what buttons are available. So we might want to press those different tabs to get access to other buttons to add more statistics, create formulas, etc. Okay, and the last thing that I should probably mention is, before we go to the live demonstration, is that we have a lot of resources available on our website. So if some of you have used FlowJo before, this webinar might be too basic for you, but you can go check out our documentation, or you can go to FlowJo University. FlowJo University will have other recordings about other topics that might be useful. If you're looking for something specific, you can always go to the documentation or FlowJo University to look for that specific topic. You can always search for specific topics as well. And you can find previously recorded webinars on our website if you go to flowjo.com. So all those are good resources you can find on our website for getting additional information. Lastly, if you want to get support, if you have any questions whatsoever, any question at all about FlowJo, feel free to email flowjo@bd.com. Those emails come to me and my colleagues, and we're happy to answer any questions that you have related to anything in FlowJo. Okay, so I'm going to go ahead and get started with a live demo. As I'm getting started, feel free to throw any questions you might already have into the chat or into the Q&A. I want to note, I'll probably not do compensation to start at this live demo. Most samples get compensated on the cytometer, and it just takes some time to do compensation. But I know that's a big question sometimes people have. We have whole webinars on compensation that you can find on our website. We have a lot of different options. And so I would encourage you to check out one of those webinars if you're interested in compensation. But I'm going to get started with data that's already been compensated on the cytometer, and we're just going to kind of go from there. So as it said, you could just drag and drop the whole folder in to load all the FCS files. I have some duplicate files in here, so I just want to maybe choose some specific folders to add. The data I'm going to load in a moment is from the Flow repository. You can see its ID here. If you want to find this data set yourself, you could just search Flow repository and you can search this term. I think they might make it available with the recording of the webinar. So if you are watching this recording, hopefully you can get the data from us. But it's just some basic data. Well, maybe not so basic, but it's a pretty large panel, mostly of T cell stains, but it has a few different phenotypes as well. So it's a pretty cool, robust data set. It's comparing some different respiratory diseases with healthy controls. And so it has a lot of cool properties to it. And so I'm just going to load this data as an example to kind of work through. Something to note that'll be very helpful. So you can see I just dragged and dropped these folders in and it loads the FCS files inside of these folders. So like here's some FCS files inside of this folder. You can also see in the middle section here, it made groups for each of the folders that I had. So for instance, my SARS-CoV-2 folder is here and it made a group for that, which is awesome. Also, I have some folders within folders here. So I have a compensation 1 folder within my comps folder. So you can see it made 2 groups here. One is this comps group, which has all the FCS files that are inside any of the folders underneath comps. And the other one is compensation 1 and compensation 2, which are these 2 individual folders with their individual FCS files. So it's kind of nicely organized my data for me already. I might delete some of the repetitive folders like that one. The rest look good to me. And you can see I kind of have a bit of data here, 98 FCS files. The more data you have, the more RAM you want to have on your computer to load the data. And so that's just something to keep in mind when you're using FlowJo. It's good to have a lot of RAM available, especially if you're doing some really big analysis. Another thing to keep in mind with the data, since I'm talking about data and data storage and management right now, is you can see here on my computer, I have these little check marks next to my FCS files, my data. That check mark means that this data is synchronized with OneDrive, but I've told it to always keep the data on my device. Having local access to the data will make FlowJo run a lot faster because FlowJo has to load all that FCS data in. And if the FCS data is stored on a server, that means FlowJo has to get access from the server, basically download all that data onto the computer, and then load it into FlowJo. So it's going to work a lot faster if we tell it to always keep the data on this device. With OneDrive and some of the other storage systems, if you see this little cloud icon here next to this name, that means that these files are stored on the remote drive on OneDrive. They're not necessarily on my computer. I don't necessarily have access to that data. So to get myself access, I'll want to right click on this, say always keep on this device, and that will keep my FCS files on this computer so that way FlowJo can access them quickly and I won't have any problems with performance or slowness. It'll be readily available. So for anyone using OneDrive or a similar server, I would recommend making sure you always have a local copy of the data on the computer to make it go faster. It will work with servers sometimes, but it's just going to be slower. Okay, so I'm going to go ahead and get started on doing some analysis. Before I do, let's just orientate ourselves on some of the buttons. So again, the different tabs control the different buttons that are available at the top. For the most part, I won't be using any of these buttons, to be honest, but there's a lot of different features that are available there that are useful. Um, for most analysis, I'll stick between the FlowJo button and maybe the Workspace button. The File button is useful though because it has maybe one of the most important things, which is the Save button. Also available under the FlowJo icon here, you can press Save and, of course, save our workspace. So saving is probably a good place to start. And sorry, I probably want to save it somewhere reasonable, like my desktop. And so you can see I just saved my FlowJo analysis. It saved it as a workspace.wsp file. The .wsp file is our FlowJo, file analysis files. This file type though doesn't have the FCS data like stored with it. It will load the FCS data when I open this .wsp file, as long as it can find the FCS files. And so a good place to store it actually is right next to the FCS data. So like I can put it in the same folder here, for instance. And if I put them in the same folder, whoops, sorry, my computer just had a slowness. But if I put them in the same folder, then when FlowJo opens, it'll check this folder for the FCS files, and if they're there, it's going to load it. And even if this folder moves somewhere, as long as the FCS files are next to the workspace, it should reconnect with the FCS files. Another option, if you are moving your data a lot, maybe you're sharing it with other people, is you could always save as, and you could save as an archive file. An archive file will store the FCS files and the workspace together as one large file. That way, if you move the data around, you'll always have it connected. Okay, so many other useful buttons. But for now, let's go ahead and take a look at the other parts of the workspace. The next top section is our group section. We have the data already kind of sorted because I used some folders. I could maybe make one more group. So for instance, let's create a group. I'm just going to call it one of each. And so my one of each group, again, I press that create group button. This is what allows us to make new groups. In here, we can give it a name. There's other properties we can set as well. I tend to just to say, okay, great, let's create the group. And then what I want in this one of each group is just one file from each of my other conditions. Because who knows, maybe I want to do some comparisons between the different conditions. And so having one of each file available might be useful. I think I'm missing something, but I wasn't paying too close attention. Maybe it's a healthy control. Nope. Maybe it's SARS-CoV-2. Yeah. Okay. So anyways, you can add samples to a group by dragging and dropping in case that wasn't obvious. So I can just drag and drop to add that sample to that group. And now the data is kind of grouped together. You can remove samples from a group by deleting it. So for instance, delete. Okay. Now there's only 3 samples in that group. That sample still exists though in the other groups that it's stored in. It's just removed from that one group when you delete the file. If you delete it from the all samples group, it'll be removed from the workspace. All the samples are always stored in the all samples group, hence the name. Okay, so let's go ahead and now look at the bottom section, the samples themselves, and let's do some analysis. The samples we can see here, it gives their name, it gives the number of cells in these samples. These files are kind of big. I'd say they're on the large size. 500,000 cells is on the larger side. Some people have as few as 10,000 cells in a sample, others multiple million. To the left of the sample name, we have this little grid icon here. This is our compensation matrix. We can double click on this grid to view our compensation matrix. This is the acquisition defined compensation matrix. That means it comes from the cytometer. This user did compensation on their cytometer. Most cytometers do compensation. Usually the compensation done on the cytometer is pretty similar to what we would do in FlowJo. We have some additional options in FlowJo that might work better in some cases, but for a basic analysis, the compensation on the cytometer and the compensation of FlowJo will be similar, so we can just use the one on the cytometer. It should work great. So we can see the values of the compensation matrix. We can see what the data looks like uncompensated versus compensated. This looks great because we have this false positive signal here that's being removed. So that's what we want. Okay. So again, that was this grid icon makes our compensation window here with our compensation matrices. Let's go ahead and get started on the analysis now. To start analysis, you start by double clicking, just clicking twice on the sample here, and it will open up this first graph window. By default, FlowJo will display the forward scatter versus the side scatter. In this case, it's the forward scatter area versus the side scatter area. Typically, we want to use area parameters. There's other parameter types as well, height and width. Area has the combination of height and width parameters, so it has more information available, less susceptible to noise, so we generally use area parameters. Forward scatter versus side scatter is the typical starting place for a gating hierarchy. Forward scatter roughly measures it correlates with the size, and side scatter tends to correlate with the complexity. So these are the two most basic things we'll use to start the gating analysis here. And so you can imagine here, for instance, with this data, this is a PBMC. What we might be looking at here are some lymphocytes down here, T cells, etc. And then maybe some monocytes or larger cell types. Maybe even, yeah, some larger cell types are up here probably. For my analysis, I kind of want all of those. I might exclude some debris. The debris tends to be lower down here. It has a smaller forward scatter and a smaller side scatter. So in order to exclude that, I might just do something like this. I'm also going to exclude the really large cells up at the very top there. I'm not sure what those are. It could be a combination of things, but I'm not really interested in any large cells with this analysis. And oftentimes there can be cells that clump together, make clumps. We want to exclude those, and those will be larger, of course. So I kind of went fast. Let me do that again. I made a gate. And so this is how we subset the data in FlowJo. The gating tools at the very top here, there's a rectangle, circle, and polygon. I tend to like to use the polygon tool. Every time I click, it makes a dot. And so I just kind of click, make dots around the shape that I want to get. And you can see making lots of dots. And then I kind of connect back at the beginning. It will make this full, shape that I've just created here. I call it size and ambiguous. And then everything in this size gate is the cells I want to keep. And so you can see most of my cells are in this size gate. 97.2% of the events are inside the size gate here. So I'm keeping most of my cells and just removing some of the outliers with this first gate based on size discrimination. So yeah, so there's lots of different gate shapes we can make. Gates in general are how we're going to subset our data. This plot type is a pseudocolor plot. As I mentioned before, a pseudocolor plot shows us the density information as well as the distribution of the data. So the density information, red areas have really high densities. And when I'm saying really high, I mean really, really high, like 50+% of the cells are there probably. And then the yellow is a lower density area, so there's less of the cells in that yellow region. And then there's green, which is a pretty low density area. And then there's blue, which is just basically the outliers. And so most of our data is kind of right here with our lymphocytes or up here. And so the pseudocolor plot's a very nice way of understanding where the cells are located within this two-dimensional plot. All right, I'm going to double click on the gate here. And you can see now I'm in my subpopulation. I just have the cells that are included in my gate. And so now I can use these cells for further analysis going forward. And what I'm going to do next is I'm going to change the axis. So I'll click on the y-axis here, and I can choose a new parameter. You can see I have all my different forward scatter, side scatter, and then my compensated stain parameters. And so I'll use those later. For now, though, I'm going to look at my forward scatter height versus my forward scatter area. So forward scatter area versus forward scatter height, we use this as another size discrimination. So when cells are going through the cytometer, we expect them to be round, so the height and area should correlate. And in some cases, though, two cells will get stuck together. When it goes to the cytometer, it'll be wider than it is tall. And so in that case, we want to remove those stuck together cells. And so we can do that by excluding things that have a disproportionate area to height. Um, okay. And so again, I just chose the polygon gating tool here. I made 4 dots, connected them together to get my single cells here. So I just clicked on the polygon gating tool, clicked 4 times. I'm choosing this diagonal here. Those are probably my single cells. And these ones clumped together here to have a larger area than the height. Those are probably my doublets. And so you can see again, most in the pseudocolor plot, most of our cells are located right here, and there's just a few outliers that are probably our doublets. Okay. So next, I'm going to click on my x-axis and choose a new parameter. I'm going to choose my live dead stain. And on my y-axis, I'm going to choose a new parameter. I'm going to just make it a histogram. So I can click on the y-axis and choose histogram to get a one-dimensional plot. One-dimensional plots can be nice in some cases if there's only one parameter we're interested in looking at. In this case, this is my live dead stain. This is staining for the dead cells that I probably want to remove from this analysis. And so any cells that are positive for this stain are potentially dead or dying. This is a viability stain. It's pretty common, probably good to have in most panels. And so I'm going to go ahead and draw a gate here, taking my live cells. Whoops, sorry. Great. And so you can see, again, most of the cells are in that live cell gate. It's probably good. And then these ones here on the right, the shoulder, those ones are getting towards the positive region. Those are probably my dead or dying cells. Okay. So next, I can click on my x-axis again, choose CD3, and then click on my y-axis, look at CD19. And just to show, just for fun, I'm going to go ahead and switch my graph type. So right now you can see the type is pseudocolor. I might want to go ahead though and change that. So we can look at some contour plots, for instance. With contour plots, these are nice for black and white publications sometimes. They show the density of the cells still, so you can see the really dense areas. It kind of hid some of the outliers, but we can choose show outliers to see those as well. So contour plots can be very nice for black and white publications. We can change the contour level to see more lines or less. Some other plot types we have available density plots, similar to contours, except they're showing the density information in a different way. Zebra is like a black and white pseudocolor almost. Regular dot plots are kind of boring, but we can use them. And then heat map statistics allow us to include a third parameter that we can then see the expression of here on these plots. So for instance, something like CD4 will only be expressed in our T cells, which should be CD3 positive here. So we can kind of see that there. There's like the green color here might just be because there's some false positive signal coming from some of the B cells over here, but in general, right, this is the yellow positive signal for our CD4. Okay, I'm gonna go back though to plain old pseudocolor, like it the most, and let's go ahead and draw a gate. I'm gonna use a square gate this time just to mix it up, and take my CD3 positive cells, which are these ones. Because CD3 is on the x-axis. And then let's take my CD19 positive cells, which are these ones. These will be 2 sister gates. So you can see every time I've been drawing a gate here, it makes a subset in the workspace over there. And so far, for the most part, they've been subsets of the parent population. So they've always been underneath the parent. All of the cells in the live gate are also in the single cells gate. And so the live gate's coming from the single cells, and the CD3 and CD19 gates both come from the live gate. Now, though, we're going to go split and go 2 different ways. We have a CD3 gate here. This is where we'll do the rest of our analysis, just looking at those CD3 positive cells. The CD19 cells I have here, I can do statistics on them, but I might not do any more gating on them if I'm already, if I don't have any other B cell markers, for instance. Okay, so to continue on with my CD3 population, I'll double click here. I see there's a question in the Q&A. Um, okay, yeah, so there's a question about how I did my live dead cell gate. This isn't the best live dead marker, I will say. So I just took, um, so oftentimes the live dead, so there's some very clean separation of markers. Like for instance, let's look at the CD4 and CD8 real fast. So you can see CD4, for instance, here is there's a very separate positive population from the negative population, two distinct populations. Sorry, excuse me. And then with the live dead stain, though, there's not as much distinction between the live cells and the dead cells. The viability stain will stain all the cells a tiny bit, and then hopefully it stains our dead cells to much greater degree. But sometimes the two populations aren't going to be completely separate. It'll be like a shoulder of the one population. So here with this live stain, this dead stain, I guess, there's a Gaussian curve. That's our negative cells. Those are the ones that we're interested in keeping. And then there's this little shoulder here that comes off of it. And some point in that shoulder is where it separates from the live cells to the dead cells. Um, with a single stain control or some sort of FMO, we can maybe see where that difference might be between our positive signal and our negative signal. Um, in this case, I'm just kind of eyeballing it because, for the sake of some past analysis, it might not hurt if there's some dead cells that are mixed in. We can maybe remove them later. Um, yeah, I'm just drawing an arbitrary threshold cutoff here. I'm trying to estimate where this Gaussian curve ends and cut off there. And then everything above that should be our dead cells. Sometimes we'll see cleaner separation, but yeah, in this case, I'm just kind of estimating based on the Gaussian curve where I think that negative population ends and the positive one begins where our dead cells begin. So hopefully that helps a little bit. Okay, so we're going to look back again at the CD3 positive cells, which are here. And we're going to look at CD4 versus CD8. Okay, so CD4 versus CD8, two hallmark CD3 lineages. You can see they separate pretty nicely, but there's also a lot of white space on this plot. And so I just want to demonstrate how we can change the transform. These are pretty well separated, but we can change the transform to get even better separation. You can change the transform using the T button here. So if we press the T button, we can customize the axis. This will open up this window here that allows us to adjust the transform. Setting a good transform is really important, and it's probably actually the first thing we want to do with our data, just to make sure the populations are well separated. It'll help us, separate our positive from our negatives. If we're doing any machine learning or any additional tools like that, we're going to want to have well separated populations. So the easiest thing to do while adjusting the transform, I have my maximum's too high here, right? The x-axis goes beyond 10 to the fifth, but my data really only goes near 10 to the fourth. I really don't need that last extra decade of space visually. So I can decrease my maximum here, and you can see it will spread out my data more across the axis and get a better separation between the negative and positive populations. The default scaling in FlowJo, as I mentioned, is bi-exponential. Bi-exponential is a combination of linear and logarithmic scaling. So it's linear near the zero, and basically what we're just using that for is to compress those logarithmic decades near the zero because the difference in intensity value between 1 and 10 is not very significant, but the difference in intensity value between 10 and 100 is more significant, or 100 and 1,000 is much more significant. So with bi-exponential scaling, we can still have significant differences between our 100 and 1,000 range, but we're maybe not paying as much attention to that first decade. So anyways, I can decrease the maximum. I can, and bi-exponential scaling, I can change the width basis. That will change how many decades are compressed near the zero. And in general, we just want to make sure our negative and positive peaks are well separated. And so here I have, actually kind of 3 peaks, but really 2 clean peaks. Our positive cells are over here. This is our negative. I think there's some false positive signal, but that's also probably negative. If they weren't well separated, we'd want to adjust maybe the width basis or some other parameters to try and make these two peaks better separated. But this looks pretty good, so I'm going to go ahead and apply this. And we can do the same thing on the y-axis, just decrease the maximum a little bit and hit apply, just to spread out my data more. That looks pretty good. So we can go ahead and draw a gate. I'm going to use a quad gate here. A quad gate will split the axis into 4 different quadrants. I'll have my single positive cells, my double positive cells, my double negative cells, and my single positive cells for the x-axis again. And so you can see it split my data up into 4 quadrants. I have 4 different populations now representing each of these quadrants. So now I have my 2 main populations I'm interested in, which are my CD8 positive cells here, and my CD8 negative cells, or sorry, CD4 positive cells here. And so I probably want to use those populations going forward to do additional analysis with my CD4 and my CD8 cells. And then these 2 kind of junk quadrants here, one of which is maybe some double cells interacting with each other, and maybe a double negative, which is just other cell types that got mixed in. Okay, I see some more questions in the Q&A, and feel free to keep asking them. Sorry, this one's done. Okay, I see. Okay, so we've done a lot of gating now. I'm gonna go ahead and stop my gating analysis. I have more markers, I could draw more gates, but let's look at some of the other tools in FlowJo. I'm gonna look at the layout editor, which is this L-shaped button at the top of the FlowJo workspace here. I'll press the L button and it opens up this new window, which is my layout editor window. In this window, like the FlowJo workspace, I have different tabs at the top: File, Edit, Object, Arrange. They give me access to different buttons. In general, I'll mostly stay on this first tab, which just says Layout Editor. And this is where the most generic tab, where I can make new layouts using this plus sign here. I can create new pages to create new images on. And I can also work with this main page. I can batch across different samples to create the same layouts for multiple samples. So let's go ahead and make our visuals. Looking back, I actually noticed something. So I've done all this analysis, but I've only done it to this first sample, this F12 sample. I haven't done any analysis to my other samples. Let's do that really fast. So I'm gonna, before I do my layouts, apply my analysis to the rest of the samples. I can do that just by dragging and dropping a gate onto the group. That will apply that gate to this group. I can also select multiple samples to apply multiple gates to the group, and I can right click and I can say copy analysis to group to copy multiple populations to the group. Okay. So I made these gates on this first sample here. Let's just open up a few of the gates just to see them. And so you can see these gates here I made on this first sample. They look okay. But they might not look okay on the other samples. So let's take a look at how these gates look on the other samples. One fast way to see all these gates on the other samples, if I open these graph windows like this, I can hold down the command key on my keyboard. Nope, sorry, the shift key on my keyboard. Click on these arrows, click on the left or right arrows, and it's going to move to the next population or the next sample in the group. So it went from the F12 sample to the A12 sample. We can tell what sample it's on because it has this little diamond icon. That means that's what we're looking at right now in the graph window. And so if I hold down my shift key, click on these arrows, we can move through the other samples. You can see the populations are changing slightly. In general, they are sticking within my gate, but like for instance, this one has gone a little bit above my gate. So maybe I want to adjust my gate a little bit. So I can just move these nodes to adjust the gate to include all these cells, make sure I'm not losing some of the cells I'm interested in. When I adjust a gate, you can see it has changed from the group color. So the group color is this blue color to this kind of dull black color. And the dull black color means the gate is no longer the same as the rest of the group. It's going solo. And so if we look at, for instance, the next sample, you can see this has the original gate on it, but then this gate has that unique shape to it. So we could keep them different, that's fine. We could also apply this new gate that I've made, or the adjusted gate that I made, to the group, replacing the old gate. I can do that by right-clicking and saying copy analysis to group. That will copy it onto the group, replacing the old gate with this new one. So now all the samples should have this new gate, and you can see that going forward. Okay, I see another question. Sure. So there's a question about, oops. There's a question about when I did the quad gate of the 4 quadrants. So if I want to see that gate again, I have to choose the parent population I made that on. So I made it on this subpopulation here. If I double click on this, we'll just see one of the quadrants. So if I want to see all 4 quadrants, I gotta look at the parent. So I can double click on CD3 to see that. Another option though is if I double click on the subpopulation, I can press this up arrow, and the up arrow will take me to the parent population so I can see what gate was used to make this population. So I like using that up arrow a lot to find the parent populations of whatever I want to look at. If I want to adjust the 4 quadrants, if I want to adjust the gate, I can just kind of click on it and move it around, and that will adjust what is in the quad gate. There's actually ways you can click on just the line, so you can just move one section around if you wanted to. So yeah, there's a few different ways we could adjust the quad gate like that. I'm also not sure if this is what the question was getting at, but there's also, when I was looking at this data, I transformed it. So we can transform, change the scale of the data using the T button here. You can say customize access, and we can change the scale. So for instance, I can add white space to it just to show a difference, and it's going to add more white space on the right-hand side of the x-axis here. And I can take that away by adjusting this transform again using the T button. Okay. And then I think there's a question about why I set this gate where it is, I think is what and so I basically chose this as the point for my quad gate because so you can see here again the yellow or the green regions are where most of the cells are located. And so there's a pretty clear separation of the green regions from each other. There's outliers, especially on the negative side here, are the CD4 negative between my CD8 positive and negative. There's some outliers that go between the two. I'm just kind of arbitrarily setting it in the middle of those. But again, if I adjust this, you can see right now this is 20.1% of my cells. I move this down here, it's 20.3. So it's not really significantly changing when I move the gate what cells are being included in here. Unless I get really high up into this yellow, then it's going to change it significantly. But yeah, I'm just kind of setting it sort of midway between our positive and negative regions, trying to get like the positive half of the cells and leaving out the negative side of the cells. Okay. So let's look at the layout editor now because I promised to look at it and we only have 10 minutes left. I'm going to copy this analysis to group just so they're all the same again. Okay, so I'm going to go back to my first sample here. Now let's go ahead and copy some graphs into the layout editor. I can do that by selecting the populations here in my workspace and then dragging and dropping them into the layout, and it will make these plots in the layout. I multi-selected, so I made many, but let me actually just select one just to show. So if we select one population, drag and drop it in, it's going to make one graph for that, whatever that population is visualizing, whatever I was looking at last in the graph window, which in this case was my forward scatter and side scatter for that first population. And if I want to see multiple graphs, I can multi-select. So I'm using shift click. You can also use the control click or the command click to select multiple populations. And then you can drag and drop them into the layout editor to see multiple populations here at once. I'm going to zoom out. There's some zoom buttons in the bottom left-hand corner. I'm going to kind of adjust this to fit all my graphs in one page. So these page breaks, you can see the page breaks here. I can move these around to fit my graphs into one page. And I'm going to move these plots. When I drag and drop a population into the layout editor, it not only makes the plot, but makes this little legend that tells me what sample I'm looking at, what gate I'm looking at, and how many cells there are in it. Since they're all the same sample, I'm just going to delete this. I don't really like it. But we can always edit these legends and change what text is inside of them. If you just double click on them, you can edit them. But I'm going to delete them all. Okay, so I'm kind of making these plots grouped together so that way I can see them all on one page in a PDF if I export this to PDF. Um, or maybe like one slide in a PowerPoint or something like that. So I kind of just can drag these plots around to kind of orient them near each other. Some other things you can do in the layout editor. So again, different tabs control the different buttons that are available to us. I'm going to go down here. There's some buttons. There's this A here. That's text boxes. So we can make a text box. I'm going to go ahead and type some stuff into it. So I'm going to type the word sample. There's this cool feature in the text box in the layout editor. If you right click on the text box, you can say insert keyword, and you can select an FCS file and insert a keyword from that FCS file. So in this case, I'm looking at the F12 file, so I want to make sure I choose that same file. Doesn't really matter, but yeah, F12. And then I'm going to choose to insert the $FIL keyword. So this $FIL keyword is the sample's name. It's the name that was written into it by the cytometer. And I'm using that keyword because then, let me zoom in a little bit so you can see it. Then I can see what sample this is. This is nice because, so you can see the word sample here is normal, it's just text. So sample is going to stay the same if I batch this layout. The $FIL keyword is kind of giving me whatever that keyword's name is, but it has those green or red dots around it. I'm colorblind, can't tell the difference, but it has those dots around it, which indicate that this keyword value will change depending on what sample we're looking at. If we're iterating the layout or if we're batching the layout, it'll change with each of the samples. So it should change for each sample, telling me what sample I'm looking at. Okay, I don't like the outline, the lines that are around my text here, so I'm going to go ahead and get rid of that. Let's choose no line. On the right-hand side, there's this properties window. It's really nice for all kinds of things. For instance, text. I can make my text larger, which I kind of like. Perfect. Some other useful tips in the layout. It's might be too big actually. I want this all to kind of fit together, so let me maybe make it a tiny bit smaller. Yeah, maybe that. Cool. So I'm going to stick this at the top here. That's looking like it's going to be a pretty nice page in my PowerPoint or my PDF. Some other ways you can change the properties of the layout. Let me make this bigger because I'm sure you're all probably really tiny on your screens. If I want to change the properties of the graph, first of all, I can right click on the X or Y axis to get the parameters and choose a different parameter. I can also double click on the plot to see the graph definition window. In this window, we can change a lot of the properties of the graph. For instance, I can change it from a pseudo-color plot to a contour plot if I wanted to, or I can set some other plot types as well. I like pseudo-colors. Let's go back to that real fast. So yeah, double clicking on a plot though, we can change its properties in this graph definition window. Something else that's useful is you can change the way the axes are displayed. So I always think the axes are too small. Under the fonts tab here, I can make the axis font bigger, which I really appreciate. So I'm going to make the text maybe like 11 and then the labels maybe like 14 and just make it a lot bigger. So we can see that makes the axis font bigger. Just did it for that one plot I was selecting, but if I wanted to select multiple plots, I could click and drag to select multiple and then double click on them and then choose 11 for the axis numbers, 14 here for the labels, and it will apply it to all the plots I have selected to make their text bigger and more legible. So that looks pretty good. I see there's a question, so let's look at the Q&A real fast. All right. No question. So let's go ahead and create a batch report now. So to make a batch report, what I'll want to do is I want to come up here to this section. First, I want to choose iterate by. There are some different iteration options. The simplest and most straightforward is sample. This will just go through every sample in my flu group and just make these same images for those samples in that group. So we'll just make the same images over and over again, which is great. There's some other options as well. There's panel and keyword. Those are more advanced. We have some documentation about how to use them. Panel allows us to look at if you have multiple samples like together in one layout and you want to iterate that over a group of samples, you can do that with panel. And then keywords even more complicated. You can use two keywords to decide what samples you want to iterate across. Um, Over here on the right, before I create my batch report, I'm going to want to change some of the settings. I like to make this column of one, and since I've gone to all this work to put them all, like all these images on one page, I'm going to want to keep them on separate pages when I do my batch report. So let's go ahead and hit create batch. And that makes these images here, which is perfect. And so now I have this nice looking batch report full of these different images of each of my samples. You can see the text name is changing for each of the different samples, so I know what sample I'm looking at and each of these different images. If I want to go ahead and export these images, I can export them as a PDF. Under the File tab, we have this Export button, probably the most important button. Again, that's File, Export, choose PDF. Then I can save this on my computer. I'm going to choose to save it on my desktop. Press Save, and it will make a PDF on my computer. Sometimes if there's a lot of graphs, which is the case here, it'll take a second to make that PDF, and then we can open it and look at our layouts. Okay. So I'm almost out of time. Whoops. I'm almost out of time, and I haven't even shown the tables yet, so let's go ahead and take a look at that. But here's just some layouts just to see them. Cool. All right, so our table editor, to go quickly through it, is this little grid icon here. It's located a few other places as well. We can click on the table editor icon to open up this new window to make our statistics. The most basic statistic we have is the frequency of parent, which is the 17.5% here. If I drag and drop this into the table editor, it'll create this as a statistic there that shows the frequency of parent. Usually I don't want the frequency of parent. There's more interesting things to look at. So for instance, I might want to make some other statistics. I can do that by going to my Workspace tab here. And then there's this, so under the Workspace tab, there's this statistics button. And I can use this to add statistics. An easy option is I can do frequency of, and so instead of doing frequency of the parent, I often want to take a frequency of live, and I can do this for all my different populations to see what's the percent of my CD8 positive cells within my live cell population. That's kind of an interesting question. And so then I can get this frequency of live. I can drag and drop this onto other samples to see that same statistic on the other sample. So for instance, 10% of my CD8 cells are, 10% of my live cells are CD8 positive, and 44.5% of my live cells are CD4 positive. So that's interesting statistics. If I want to get them to the table so I can apply them to the rest of my samples in the group, I can drag and drop them into this table editor, and this will then allow me to generate the same statistics for the other samples. I can generate the statistics by pressing the Create Table button here. This will create this table with each of my samples that are in my flu group here. And now you can see it's showing me the percent of my CD8 within the live and my CD4 within the live for each of these different samples, and it actually varies quite a bit. H6 has almost twice as many, or almost 3 times as many CD8 positive cells as my first one, for instance. So we can get some statistics that way. The most useful place usually to put the statistics is in a CSV or Excel file. So where it says display here, we can click and we can change it to file. This allows us to save it to a CSV or Excel file. This little destination here, I clicked on that. That opens up this Explorer window here. I can choose a place to save my file, table. I'm going to call it table intro demo, July 11th. And so now if I hit create table here, it'll create a new CSV file on my desktop. I can open it in something like Excel, and then I can see those statistics here and do further analysis with it here. Okay. Some other things to show. So if I go back to my CD8 positive population, I can add other statistics as well. if I go to add statistic here, it allows us to add multiple statistics. Um, so I can choose something like a median of, for instance, like CCR7 maybe or something like that. So I can add a median fluorescent intensity value. Sometimes people will call this MFI. So I can get a median fluorescent intensity value of this population of a certain marker. Um, I can choose multiple statistics to use with that CCR7. So for instance, I can do a standard deviation as well. And I'll get these two statistics now. To multi-select, I'm just holding down the Command key on my keyboard since I have a Mac, or you can use the Control key and then click while holding down the Control or Command key to multi-select. And I can go ahead and add multiple statistics this way. So you can see I have this median of um, CCR7 and then the standard deviation of the CCR7. So if I drag and drop that into this table editor, I can then go ahead and let's just do it to display again. It makes two extra columns with those statistics. So you can see the median and standard deviation are there. You probably noticed that these columns have pretty long names. They're pretty precise about what population we're looking at. Since we're making these tables, though, we should know what populations we're looking at, and so we can rename these columns to whatever we want. So for instance, for this, I can name it, I'm going to call it MFI, which a lot of people will use for median fluorescent intensity, though some people mean geometric mean fluorescent intensity when they say MFI, so it can have multiple meanings. But I'm going to say MFI CCR7, and these are my for CD4 positive, or is this my CD8? Oh, this is my CD8. Um, so I'm choosing to look at the MFI for my CCR7 for my CD8 population, and this is my standard deviation of the CCR7 for my CD8. Typed that wrong. Okay. And so now if I hit create table, you'll see it uses those new column names when it makes the table. So it's maybe something a little more understandable and legible. And I can also create that to a file and again, make that CSV file. It's going to make a second CSV file here on my computer with those new columns with the new names. So you can see those new names are here as well. So that's a brief overview on how to get started with FlowJo, look at statistics, look at making images. And so hopefully that's useful for getting started on the analysis. If you have more questions, I will stick around. I know we're actually a little past time, so feel free to depart. But if you have more questions, feel free to stick around. I'm happy to answer them. And I'll try and get into the Q&A and answer the questions that are in there. Oh, there's a question about when you'd use median versus geometric mean for the MFI for flow cytometry data. It's a good question. People will use both, is the short answer. Both are pretty common. Both are pretty accepted. They're just different ways of describing the central tendency. And so just to look at some Gaussian curves here, let's just look at some Gaussian curves real fast of the positive population here, for instance. And so this is a pretty clean Gaussian curve. Let me see what else I have that might be more interesting. Oh, CCR7, why not? So if I took the median of this population, it's describing the 50th percentile, right, of the data. So it's, if I split the data evenly in half, had 50% of the cells on one side, 50% on the other, wherever that middle line is, that's the median. And so it's a useful statistic for this type of data where we have logarithmic intensity values. So obviously the intensity values up here are very, very big. They have very high, very big values. And they get exponentially bigger the further to the right you go. And so they're going to contribute more. If you use the standard like mean, for instance, the right-hand side is going to contribute a lot more than the left. And so in order to balance that, we use a median, which is just the 50th percentile. So it's just the dead center of the data, wherever that is. The geometric mean is the mean, but it's also accounting for the scaling of the data a little bit. So the logarithmic scaling at least. And so it's a mean calculated in a logarithmic scale. So it's describing the central tendency, but it's taking into account the scaling. So it's like as if instead of paying attention to the numbers on the axis, we just looked at like what bin the data was in. It should be the central tendency, of that logarithmic scale of the center of that. it's a pretty poor maybe definition of what a geometric mean is. But basically, you could think of it as the mean of the scaled data that is the center of that, versus a regular mean would just be the mean of the raw data, which would be skewed in a logarithmic scale very far to the right. Um, so hopefully that helped a little bit with some insight onto which MFI to use. Again, a lot of people will use either median or geometric mean. They're both pretty appropriate for this type of data. Something like a mean, just a plain mean, would not be appropriate. Um, Sorry if I'm speaking too fast too. I'm always worried about running over time, which I've done. Okay, and then there's a question about where we can find a recording of this webinar. So we can get these recordings. Might as well go to the website. Let's do a little tour. Um, Move on Firefox. Go to flowjo.com. And then under the Learn tab here, we can choose webinars, which maybe you've already done to see this one today. But then under at the bottom of the webinars page, it says recorded webinars. We can click on this to see previously recorded webinars. So for instance, here's an intro to FlowJo that was recorded not too long ago, similar to this webinar probably. So you can see the recording here. Sometimes they'll share the data, sometimes they won't. It depends. But yeah, you can see the recording here. And then I know, for instance, I did this phenotyping webinar a few months ago, and you can see it has the data linked below. So you can get the data for some of these webinars as well. It's actually the same data in this webinar as that phenotyping webinar, so you can find this data there. But yeah, you should see this here in maybe 2 or so days. It'll probably be uploaded. Awesome. Okay, I see some other questions about access to this webinar recording. Yes, so again, it's on this website. You can find um, on our webinars page, and then under previously recorded webinars, we can find the recordings. So hopefully that helps. There's also actually some other really good webinars on here. So for instance, if you're just getting started and you want to do compensation, there's a whole webinar on compensation. So you can kind of see all the different ways to do compensation and figure out what's best for your data, or you can just see the basic way of doing it and then skip the next 20 minutes. Um, there's a webinar on QC and normalization. Quality control can be useful for cleaning up the data, so might be a good one to check out if you're getting started. And there's plenty of others. There's high dimensional webinars if you're looking at some 30, 40 color panels, maybe you want to do machine learning on the data. Those can be good for that. So there's a lot of different webinars you can check out here. Also, there's plenty of recordings under Learn. If you go to FlowJo University, we have each topic broken down into recordings here. So for instance, under Getting Started with FlowJo, you can see all these different topics like traditional compensation, for instance, or just the gating hierarchy and how to manage it. So you can see these individual topics broken down here in these recordings. Okay, more questions? Feel free to ask more questions. Well, I'll stick around for a few more minutes to see if anyone else has questions. Otherwise, I'm going to wrap up. But yeah, thanks for joining me today. And if you do have any other questions, you can always, or if you want us to look at something specific to your analysis, you can always email us. Again, that's flowjo@bd.com. BD as in Becton Dickinson. That's flowjo@bd.com. If you email there, it'll come to me or one of my teammates, and we're always happy to answer any questions, big or small, about FlowJo, anything at all about FlowJo. Awesome. Okay, so there's a question about the x and y axis and the positive and negative values. So yeah, so my x-axis right now is just it's just a one-dimensional plot. So this is perfect, really. We can see from my CCR7, there's some positive intensity values, and there's also a couple of slightly negative ones. Um, so these values are just the intensity values written into the file by the cytometer. They're in a logarithmic scale, so tends to be the best representation of intensity values. Um, so like 10 to the 3 is a intensity value of 1,000. Intensity values are all relative, so depending on the cytometer, you'll see your intensity values at a different scale. Bigger isn't better. Some cytometers will just use larger numbers than others. The intensity values are affected by things like the gain, the voltage, the stain concentration. But really all we need is we need the positive signal to be separated from the negative signal. In this case, CCR7 is not like a phenotypic marker, so it's not there's not a clear divide between positive and negative pop signal for this marker. Um, like our CD4, for instance, had a clear separation between positive and negative signal. Negative signal is never it's not always negative and it's not always zero. So there could be background signal that could cause the negative signal to be slightly greater than 100 or greater than zero. In this case, my negative signal is kind of centered on zero, more or less. This negative peak here is pretty close to zero. But there's going to be some spread of that negative signal. Um, it can spread into the positive for multiple reasons. First of all, there's background subtraction that occurs on the cytometer. So I was trying to remove background noise from the equation. And so sometimes the negative signal and the background noise look kind of similar. Doesn't really get picked up by the laser. So it'll have a value of zero or even less than zero if it was less than background noise, just due to the variance. So that's fine. Negative values are pretty normal. Compensation will also make values slightly negative sometimes. So compensation does subtraction. It subtracts the false positive signal from the cells. So cells might have a slight amount of false positive signal in it that gets corrected by compensation. And then just due to the variance, it's going to have, the Gaussian peak should be centered at the zero, but some of the cells might be slightly negative, but that's fine. As long as they're just slightly negative, especially, that's fine. Okay, hopefully that answers that. Yeah, so if you want a certificate for this training, feel free to email, again, you can just email flowjo@bd.com and I'll connect you with the people who can get you that certificate. We do have certificates for attending our trainings. If you just want like something to print out, it's a PDF. But yeah, feel free to email us at flowjo@bd.com and we can provide you with your certificate. Okay. So yeah, feel free to drop any last minute questions in. Otherwise, probably give it a minute or two and then I'm going to close the webinar. Thanks again, everyone, for joining today. Hopefully this was helpful. Hopefully I didn't talk too fast that you didn't understand. Um, but yeah, there's a lot of great features in FlowJo and definitely a lot to explore. Okay, awesome. So I'm going to go ahead and wrap up and close this room. Yeah, I hope everyone has a good evening and thanks again for joining me for this webinar.